I am here to speak about spatial comfort in industrial buildings. We have designed very many industrial buildings across the country, and in certain cases handle sizes beyond comprehension. Recently we completed a project in Calcutta where 8,500 workers would work in a single shed. And imagine these people's lives inside these industrial units. Are we giving enough importance to them? How can we improve the spatial comfort for these people who are the pillars of these industries? Most of us start with discussing about the processes, the production requirements, the troubles that the process people are facing, and they rule the entire conversation during the initial period of discussions. But as architects, we have a bigger responsibility of enhancing the human experiences of these people who are going to use this facility during production 24/7. How can we do this? We can do this through quality of life, obviously, quality of air, which is very, very important, quality of interaction. There are these social possibilities within an industrial unit, and obviously the aesthetics of building interiors. Siddharth very nicely pointed out and showed us beautiful examples of how this can be enhanced. We do it religiously in most of our projects, and we try to educate our clients as this is becoming very, very important. A lot of industries come to us running during summer that their laborers are protesting, they have a problem there, and then we sit with them and give them a big report by the time the summer is gone and the problem is sorted out. But I think as architects we should sort it out initially itself. Though we are talking of spatial comfort inside industrial steel structures today, I would touch upon the master plan, because master plan obviously is the start point for everything. You can plug the green spaces, social facilities, you can plot the pedestrian movement into these areas, and also orient your buildings in such a way it can get the maximum wind inside and light inside. All that happens during the master plan stage. I will not go into that because it's a steel building conference, so let me jump into the building itself. This is one of our recently completed projects. It is in Terwai, Kandigai, and it's a simple 1 lakh square feet, 120 meters by 80 meters project, but we sat with our in-house teams and our CFD analysis team, simulation team to get the best out of such a building. So what you see is a series of north lights which are flared up and turned around to allow a lot of air and light inside, which I'll show you later in the slide of the presentation. There are these docking areas that are attached to these sheds on the sides, which also works as a wind catcher, which I will show you how we have managed to do that. Soon after we get the project, we discuss with the process team and we get an idea of the building, we immediately do a digital twin. This digital twin is used for various simulations in the process before we finalize the sizes of windows, size of north lights, all that. So this digital twin first checks with the entire your regular climate analysis, sun path, everything, and then throws out a lot of data, and we have to concentrate on this data to get to some kind of an inference. When you go to the visual or the light aspect into the building, basically our building is well lit in the initial stage itself. But these kind of simulations also helps us in iron small things like These are slightly lesser in comparison to this kind of a light here. So we increase the polycarbonate on top and get the even on the light inside. At the same time, we as architects don't like an engineering solution with clear light everywhere. We also like to play with light and shade. So we also give that little play possibility in the projects. So wherever these daylight sources are, we will try to tap it in and try to get this kind of a play of light, use of colors, and the materials that we use inside on the floor, how it reflects the light, whether we are able to get some kind of a connection between what is happening outside in terms of particle weather, whether we are connecting the people inside, or is it always with artificial light. So in most of our facilities, I can confidently say if you just walk in now, nobody would have switched on even a single light. This is how we do this digital simulation and then get our lighting aspect corrected. And like I was talking about, there is a nice amount of light in one corner, and there is another varying degrees of light in another corner, but at the same time, the minimum requirement of 350 lux will be maintained throughout, and it will not be too much of variation at the point of work. It won't be glaring, it won't be too less. So I will move through these light slides. Now going into quality of air. This is very, very important for us because this is one thing that is becoming a major issue, and also this is the only place that I can work towards a natural system of airflow on a person, because most of my projects, commercial, residential, everything is becoming air conditioned, which we do not like. Here is one place where I can play with gravity flow of air as well as the amount of air that touches my skin, which is the most important comfort level that we can get. So in this particular project, we have turned all the dockings. If you see here, these docks are turned towards wind direction this side, these docks are turned towards wind direction this side to catch the wind in the various seasons. Our first digital twin would have shown us between which month to which month, which direction wind is passing through and things like that. And we have, in this project, oriented the docking bays as wind catchers in those directions. Also, we have done a vehicular analysis in the master plan level to make sure these docks are really workable. When the vehicular is moving in different directions, these docks may not work. So that was also planned initially itself. These openings are very, very important. As you open out, most of the steel structures, you will see all the ventilators on top, which is of no use. This air that passes through the top short circuits, the people who are going to use this, and then it is moving away from where people are really wanting that kind of airflow. So we restrict any air movement from the external envelope at that level. We always keep it below 3 meters and try to get in as much as air as possible. And then we try to exhaust this air gravitationally, not through any forced methodology, but through gravity on the roofs or through the north lights, openings in the north lights. So our simulation today is so extensive that we are able to get 8 kilometers an hour breeze inside this facility. So which is I don't think, I have not done anything like this before this, but we plan to do this in all our buildings in the future. 8 kilometers an hour is like a gentle breeze inside, and I have seen all the docking facilities in this particular project left open by the users. Because they have seen that as wind catchers, they want this to be left open. Most of the other facilities where we have seen, or where we have also designed all these dockings, rolling shutters are always kept shut. Because it's very glaring when you come closer and the heat gain is too much inside. So this particular system of pushing the docking zone slightly away and also turning it around helped a lot in allowing this wind to come in, and also the users warming up to that idea. In this particular project, to achieve this 8 kilometers an hour breeze inside the facility, we have kept about 6 HVLS fans, which sometimes works on the reverse. When the heat goes up and there is a temperature sensor which makes it stop working on the forward direction, and it works in the anti-clockwise and starts exhausting the air. It just sucks out the air, but it is not a regular exhaust motors. It just pushes the air up to the grab ends on top, or north-light ventilator that we have designed. So much of air just pushed out, which will force the outside air to come in through these windows, louvers and dock wind catchers. If the outside wind is not helping me, I use these 6 fans and it's working very well. Next is, after the quality of light and quality of thermal comfort or airflow, is the quality of interaction. We always make sure the social spaces inside our industrial facilities, design with this industrial facilities very neat and clean, for them to spend a little time there and socialize. These are the spaces that are really required. And finally, all these adds to the aesthetics of the building, the colors, the light, the play of air, and all this. Even I have to mention our structural engineer, Dr. L.S. Jayagopal. He sits in Coimbatore over a phone call of 5 minutes. He really understands our structure and makes it float. That's what I would call it as. You won't feel anything that is heavy in my buildings because of Dr. L.S. Jayagopal's inputs. And there is this possibility of providing forest within an industrial facility also. There is, most of the processes are, there is a pre-process and a post-process. So in between we can have some kind of green areas.